Hello everyone. Today we will discuss about the rotational EMF. So rotational EMF, as the name itself indicates, that this EMF is produced due to the rotation of some object, right? So let's say, for example, if we have this rod having length L and this rod is rotated like this, and due to this rotation the EMF produced across its length is called as rotational EMF. So we can mention the EMF induced due to the rotation of a rod in magnetic field. This is called as rotational EMFs. So first I'll draw this rod which is having total length L and this rod is rotating in the magnetic field. So due to the rotation of this in the magnetic field, this rotational EMF is produced. Now say for example this magnetic field is normally inward. That means you can say this is normally inward. This magnetic field is normally inward and the rod is rotating like this in this magnetic field, right? So if we are saying that this value of EMF, motional EMF, is due to the motion of a rod is simply B V L. So if we are talking about the production of induced EMF in dl length, then we can say that dE is equal to BV dl, right? So this is the basic formula of motional EMF. And if we are talking about in dl length, small length dl, right? We also know that the formula for velocity which relates it with the angular velocity, because this rod is moving, right? So it is rotating actually. So this is what is it doing? This is actually having angular velocity, right? And at any instant it is having v linear velocity which is tangential, and it is moving with angular velocity omega, right? So v is r omega. R is the radius of the circle which it is making. So we can say that here r is equal to L, which is the radius of the circle actually. So what is happening here? V is equal to L omega can be written. Now from here, if I put this value, this equation as 1, this equation as 2, so from 2 in 1, what I can write is dE is equal to B. For V I am writing L omega and this is dl. right? Now if the angular velocity is this is constant, that is uniform. So if I have to find the total EMF, for total EMF I need to integrate it. So what will I get? Integration of dE is equal to integration of B L omega, and this is dl. So I can write integration this E, and this is 0 to L limit. Here I can write 0 to maximum EMF limit. So this will be uniform magnetic field, so outside this, uniform angular velocity, so outside this, and this will be integration L dl. So this will be B omega, and this is L square upon 2 is the integration of L. Again putting the limits, this will give me the same value. If you remember, this can be written as this, and this will be upper की जगह upper limit we are putting, minus 0 we are putting, so this will be actually B omega L square by 2. So this is the first expression for rotational case. Second expression for current we can find out. This is E upon R. This can be written as B omega L square upon 2R, and then we can write down the expression for power, that is rotational power. This will be again I square into R. So this gives me B omega L square upon 2R whole square into R. So from here power comes out to be B square omega square L4 upon 4 times of R square into R. So 1 R will be cancelled. So this gives me power is equal to B square omega square L4 upon 4 R. So this is the final formula for power. Formula for current. So this is the formula for current, and this is the formula for the rotational EMF. So this is all about rotational EMF. Hope you understood the topic. That's all for now. Have a nice day.